Technology Gayakwa Patil College of Engineering and Technology, Nagpur, and today we will discuss about the numerical or first law of the thermodynamics. Right? The first law of the thermodynamics is nothing but there is a total heat interaction is equals to the total work interaction. Now I am going to discuss about the numerical. This is a given data. I read the questions properly. An insulated cylinder of 0.4 meter diameter. It is an insulated cylinder. Here this cylinder. For example, here this cylinder. And this one is a piston, for example. Here the gases. For example, O2, N2. Here the gases. This one is a insulated. The meaning of the insulated means there is a no heat transfer between system to surrounding and surrounding to system. The value of the Q will be 0. Right? The length of the cylinder is equal to 0.8 meter and the diameter of the cylinder is equal to 0.4 meter and mass is 10 kg of the oxygen. The pedal wheel work is done on the gas to increase its pressure from 3 bar to 6 bar. When increase the pressure from 6 bar to 3 bar to 6 bar. Before the compressions, the pressure is 3 bar. After the compression, the pressure will be increases 3 bar to 6 bar. Right? Determine the change in the internal energy. First point, determine the change in the internal energy. How to calculate the change in internal energy? Second one is how to calculate the change in enthalpy and how to calculate the work done from the system. This term is final. How to calculate this term? The given data. Right? In this question, Cp and Cv are given. The value of the Cp, specific heat at the constant pressure, and specific heat at the constant volume are the given. Specific heat at the constant pressure is given 0.91 kJ per kg Kelvin and 0.62 kJ per kg Kelvin. The first thing is that the change in internal energy. How to calculate the change in internal energy in the system? The change in internal energy is equal to nothing but this one is a enthalpy change in the heat transfer. Okay, we already discussed in the theory questions or theory lectures dq is equal to this one is a mc delta t. Here specific heat, I don't know now specific heat at the constant pressure or specific heat at the constant volume, but in the internal energy cases the specific heat only at the constant volume. So we can calculate the internal energy from this formula mCv delta T. Right? This one is equal to Q is equal to or del U is equal to the this is n Cv T2 minus of T1. How to calculate the temperature at the inlet portions and temperature at the exit portion? How to calculate? In the common sense, T1 is less than as compared to T2. Common sense. Right? The T2 and T1 can be calculated from the ideal gas equations. From the ideal gas equations, PV is equal to mRT. Right? In the case of the first conditions, P1 V1 is equal to mRT1. Right? P1 V1 is equal to mRT1. That means calculate the T1 from this formula. T1 is equal to P1 V1 upon mR. We can calculate similarly T2. T2 is equal to the P2 V2 over the N of R. How to calculate the R? The R is nothing but Cp minus of Cv. The R is nothing but specific heat at the constant pressure and specific heat at the constant volume. Right? The value of the specific heat at the constant pressure is equal to the 0.91 minus 0.62. The value is nothing but 0.27 kilojoule per kg Kelvin. Now we have a pressure at the point 1 and pressure at the point 2. This value is given and this value we already calculate, and mass is also given in this questions. Now how to calculate the volume? How to calculate the volume? The volume, the heat transfer at the constant volume process, that means the volume will remain constant. How to calculate the volume? Volume in the meter cube, right? The volume is also equals to the change in area or the change in area or length of the cylinder. The length of the cylinder, this one is the length of the cylinder and this one is the diameter of the cylinder. This one is nothing but the area. Right? Volume is equal to area into length, that means meter square or meter. This one is also meter cube. We can calculate from this formula. Now area means this is pi upon 4 d square into length. Right? This one is a 5 over the 4. D is nothing but 0.4 of square into length of the cylinder is a 0.2. The volume is equal to the 0.1 meter cube. Volume is equal to the 0.1 meter cube and R is equal to the 0.27. Right? We can put the value in the equation number 1 and equation number 2, and you can find out the value of the temperature at the section 1 and temperature at the sections 2. T1 is equal to P1. The value of the P1 is equal to 3 bar. 3 into 10 raised to the 5. The value is given in the bar. We can convert it into the Newton per meter square. Okay. This one is volume 0.1. Mass is given 10 kg into R 0.27 into 10 raised to the 3. Right? Now T2, we can calculate the same. 6 into 10 raised to the 5 into 0.1. Put the value in this equation number 2. Mass is 10 kg and 0.27 denominator value is 7. This is 10 to the value of T1 is equal to 11.17 Kelvin and value of the T2 is equal to the 22.24. Right? 22.24. Now you can calculate the value of the change in internal energy. Del Q is equal to the M 10 kg, CV 0.62 and T2 minus T1 22.24 minus 11.17. 11.17. The change in internal energy is equal to the 71.98 kilojoule. This is the change in the internal energy in this